Welcome to engineering chemistry class. Today we are going to study a new unit called electrochemistry and corrosion. In this unit we are going to learn about the fundamentals of electrochemistry. This unit will explain the types of reference electrodes like calomel electrode and glass electrode. And this unit it tells us about the chemical reactions used in the lead acid battery, lithium ion battery and fuel cells. And the students will be able to identify and investigate the means of protecting metals against corrosion. And the students will understand the electrochemical nature of corrosion of metals and the protection of metals using different techniques. So these are the contents in the unit 3, that is electrochemistry and corrosion, and this unit divides into two parts. First part will be explaining about the electrochemistry concepts, and the second part will be explaining about the corrosion of metals and prevention of metals by different techniques. And in first part electrochemistry we are going to learn electrode potential, types of electrodes like calomel and glass electrode, and electrochemical series, Nernst equation, and the types of electrochemical cells like galvanic and electrolytic cells, and the batteries, the types of batteries like lithium battery, lithium ion battery, lead acid battery, then fuel cells, its applications and advantages. These topics come under electrochemistry part, and in corrosion part we are going to learn the definition, causes and effects, then the mechanism of corrosion. There are two mechanisms, chemical and electrochemical, and the types of corrosions like galvanic, concentration cell and pitting corrosion. Then the factors affecting corrosion based on the metal and based on the environment. And coming to corrosion control methods, we are going to learn the control methods like proper designing, cathodic protection. In that there are two methods of cathodic protection of metals: sacrificial anodic and impressed current cathodic protection method, and metallic coatings. There are two types: galvanization and tinning in hot dipping method, then electroplating and electroless plating of nickel. So here we are going to see the first lesson, introduction to electrochemistry and some terminology in electrochemistry, then the construction and working of calomel electrode. So introduction part. What is electrochemistry? It is a branch of chemistry which deals with the interconversion of electrical energy into chemical energy, vice versa. If you take a battery, in a battery a chemical energy is converted into electrical energy, and in electroplating or electrolysis process electrical energy is converted into chemical energy. So what is electrochemistry? It is a branch of chemistry which deals with interconversion of electrical energy to chemical energy, vice versa. In case of battery, chemical energy is converted into electrical energy, and in case of electroplating or electrolysis, electrical energy is converted into chemical energy. Right. So coming to the electrode potential. Before explaining the electrode potential, let me tell what are the substances which allow electric current to pass through them. So they are called as conductors. So what are conductors? The substances or materials that allow electric current to pass through them are called as conductors. Example: metals, graphite, some fused salts, aqueous solution of acids, bases and salts behave as a conductor. They allow electric current. So what is insulator or non-conductor? The substances which does not allow electric current to pass through them are nothing but insulator or non-conductors. Example are wood, plastic, cellulose, sugar solution, etc. Okay, and coming to the electrode potential, when a metal is in contact with 1 m solution of its own ions at 25 degrees Celsius, it may either undergo oxidation or reduction. So that it may lose electrons or it may gain electrons. That is called electrode potential. or in a simple way I am telling, the tendency of a metal which undergo oxidation or reduction is nothing but the electrode potential. So it should be dissolved in the solution of its own salt at 25 degrees Celsius. So every metal tends to develop either negative charge or positive charge on the surface when it is dipped in the own metal ion solution. Okay. So what is standard electrode potential? It is a measure of tendency of a metallic electrode to lose or gain its electron when it is in contact with the solution of its own salt of unit molar concentration, that is 1m concentration. That is called standard electrode potential. What is oxidation and reduction potential? The tendency of an electrode to lose electrons is direct measure of oxidation potential, whereas the tendency of electrode to gain its electrons is nothing but reduction potential. The copper reduction potential is plus 0.34 volt and the oxidation potential of copper is minus 0.34 volt. So what is Helmholtz electrical double layer? This is very important term in electrochemistry. Every metal tends to develop either negative charge or positive charge on the surface when it is dipped in its own metal ion solution. For example, if you dip a zinc metal in zinc sulfate solution, it will develop a positive charge or negative charge on the surface. If you dip a zinc electrode in zinc sulfate solution, it will develop positive charge in the solution and the electrode become negative. Okay. So this leads to the formation of layer of negative ions or positive ions around the metal electrode, that is called Helmholtz electric double layer. So a potential difference is set up between metal and metal ion solution, right? So the metal ion solution is zinc sulfate in case of zinc electrode. Zinc ion will dissolve as Zn2 plus and the electrode become negative. So there will be a negative ion and the positive ion around the metal electrode. So this prevents any further exchange of ions between the solution and the metal surface. So the potential difference becomes constant at equilibrium and this is known as standard electrode potential. The electrode at which oxidation occurs in the spontaneous operation of a cell is negative electrode or anode, and where the reduction occurs is nothing but a positive electrode or cathode. And we are going to see the calomel electrode, types of electrodes. So types of reference electrodes. So the electrodes are of three types: reference electrode, indicator electrode, and ion selective electrodes. What are reference electrodes? So it is an electrode of standard electrode potential with which we can compare the potential of other electrodes. What is that? The electrode of standard electrode potential, where we can compare the potential. So with the help of standard electrode potential, we can compare the potential of other electrodes. So there are two types of reference electrodes: primary reference electrode, secondary reference electrode. Standard hydrogen electrode comes under primary reference electrode. Calomel electrode comes under secondary reference electrodes. So calomel, it is a secondary reference electrode for the potential measurement. So this calomel electrode consists of a tube at the, you see in this figure, it consists of a tube. At the bottom of the tube, a small amount of mercury is placed. So it is covered with a paste of solid mercurous chloride, that is Hg2Cl2. KCl, that is potassium chloride solution, is then placed over the paste. So first for mercury, over the mercury chloride is there, Hg2Cl2. After that potassium chloride is placed. So a platinum wire is dipped in the mercury layer at the bottom, which is used for making electrical contact. Then the side tube is used for making electrical contact with the salt bridge. The potential of half cell electrode is given like E equal to E naught minus log of chloride ion. So the potential depends on the concentration of chloride ion. The potential of this calomel electrode depends on the concentration of chloride ions, and the potential increases as the chloride ion concentration increases. So at 298 Kelvin, that is at room temperature, the potential of any calomel electrode when it is connected to the standard hydrogen electrode for saturated KCl solution. If the KCl solution is saturated, then the potential of calomel electrode is 0.2422 volt. If the calomel electrode contains 1 N KCl, the potential will be minus 0.281410 volt. If the concentration of KCl is 0.1 N, then the potential will be 0.3335 volts. So to obtain the potential of any other electrode, that is half cell, when it is combined with the calomel electrode, and the EMF of the cell can be measured. So the representation of saturated calomel electrode is mentioned here, and when the calomel is connected to hydrogen electrode of unknown pH, then the cell is represented like platinum here. The E cell will be, the EMF of the cell will be EMF, that is a potential of a saturated calomel electrode minus potential of standard hydrogen electrode, that is 0. Then the saturated calomel electrode 0.2422 volt. We can write the potential of standard hydrogen electrode like minus 0.0591 pH. Apply Nernst equation, then you will get pH equal to E cell minus E, that is potential of a saturated calomel electrode divided by 0.591. So the pH depends on the concentration of hydrogen ions present in the solution. I hope you understand. Thank you for listening.